Hello, today's topic is Vert.X. It is part of the Red Hat Openshift application Runtimes. What is the Red Hat Openshift application Runtimes, or for short, Rhoar? It is actually a collection of cloud-native runtimes for developing Java or JavaScript applications on Openshift. It provides portability across multiple cloud infrastructures, allowing the developers to use microservices, containers, and DevOps automation and practice. If you look at the components or runtimes of Rhoar, you'll find the following in here. Reactive, Vert.X, which is the topic we're going to talk about today. And you also have Wi-Fi Swarm, which is a composable JEE app server, which means that you can bring in components that you only need. For example, if you don't need JMS in your particular application, you don't have to bring in the JMS component. This means that you can compose your own app server to have the minimal footprint. And if you are coming from a Spring background, you're probably going to use Spring Boot. If you're a JavaScript developer, then you may consider Node.js, which you're already familiar with. And also, you can make use of other Red Hat middleware services together with your microservices application you write using all these frameworks or runtimes. You will notice that we also included the JEE, JBoss, EAP, or Enterprise Application Platform, or app server in here. So why do we provide such an app server in a microservices framework? So it's very simple. It's for people lifting and shifting monolith applications to EAP for CI/CD pipelines, etc., running on Openshift. Right. If you look at the performance of EAP, you notice that you can actually use it for microservices as well. If you look at the memory usage and also the throughput, you'll find that under load is actually more efficient than the Spring Boot running as a fat jar on Tomcat, right? So you can see all these performance statistics here. So today's topic is reactive microservices. I'm assuming, actually this is complementary material to complement the Red Hat Monolith to Microservices Workshop. So I'm assuming you already get some information in that workshop. So this particular discussion is to help you understand the reactive microservices framework better. Now let's look at the reactor pattern. The reactor pattern simply means that when you apply stimuli to a black box, you get certain actions. Well, you can do reactive in two different ways. Like, for example, you use reactive programming, basically using event and also the callback functions, which you're already familiar with if you're using Node.js. And you can use that to build reactive systems. Reactive system may consist of more than one reactive applications working together via messages. So I'll talk more about that later. Let us first of all examine the differences between, say, Eclipse and other execution models, like, for example, JEE, Tomcat, etc. So if you look at the middle here, like a multi-threading, so everyone who is familiar with Java EE or Tomcat or Spring framework, you already understand the multi-threading, right? So whenever a request comes in, JEE or Tomcat will spawn off a thread in the thread pool to handle that request till completion. So over time, you may have a lot of threads running, and each thread will consume some memory and CPU time. Obviously, there's some overhead with that. And another model that, for example, popularized by Node.js is a single thread non-blocking model. Basically, you have an event queue, or request queue, which all the requests go through this request queue, and your single thread non-blocking event loop just take one request from the queue, process it, take the next one, and so on and so forth until it processes all of these requests. That means if you have a long-running request, then you're going to block the execution of all the subsequent requests queued in the queue. Right? So it's very important that you should never block it. So some may say, well, what happens if you have to, say, access a database to do like a big join operation of multiple tables? Then how am I going to do that? Then that's why we have a non-blocking, we have a multi-thread non-blocking model as well. So whenever you want to do some time-consuming task, you will spawn it off to a thread in a thread pool as in the JE approach. But when it finishes, it will do a callback function. You also provide a callback function. When it finishes, it calls your callback function and complete that particular request. In short, Vert.X is an asynchronous non-blocking development model. It uses the event loop. It's meant for building applications that deal with high volumes, low latency, and also you can extract the last bit of the performance from your hardware. Here is a diagrammatic view of how the event loop operates. You have requests coming in here and get queued up in the event queue, and then your event loop will take one request from the queue, process it. If it's a blocking function, we will assign a thread to do that, and when the thread finishes, call your provided handler or callback function to complete that request. For the event loop, it's very important that well, you don't actually block the event loop. And in Vert.X, we have a multi-reactor pattern. Actually, well, is in contrast to Node.js. Each core, by default, it starts with 2 event loops per core. Right? This is to make use of multiple calls in a server. This is the #1 golden rule. Never block the event loop, because as we discussed earlier, is process one request at a time for the event loop. If you have a long-running request, that means until it finishes, cannot actually process the next request, and that means that all processing stops for all the other requests. Here are some examples of blocking code. The easiest to understand is, like I said earlier, you're performing a join on the large number of tables, returning millions rows of like result. That is a long-running process. When you're waiting for the database to complete that, you're blocking all the other requests. Another example is, for example, you're doing Bitcoin mining, so you're definitely going to tie it up for a long time if you don't spoil it off using a thread. By the way, Bitcoin mining is probably not a good candidate for using Vert.X. And as I said earlier, when you program or you want to spawn it off into, well, use a thread to actually do your blocking call. So you have to call the execute blocking API. So you provide the handler, and also it will return you with like a result. So here are the prototype for the 2 calls. So if you are in the Monolith to Microservices Workshop, you'll be having like a go at these particular calls as well. So I'm not going to describe that in too much detail. As I said earlier, this video is to complement what you learn in that particular workshop. Last thing I want to mention is that there's a concept of vertical. A vertical is a programmable unit in Vert.X. It's like a module. You may have multiple verticals in a particular application, and these verticals can actually communicate with each other using messages. And when you start up your application, there will be at least 2 verticals. So why is that the case? I'll talk about that later. Now, once you have completed that workshop, you'll probably be exposed to some lab examples with Vert.X applications. So once you understand all that, so the next question that comes to mind probably is how I'm going to handle dependency injection. So if you come to my blog, I have many articles in there. For example, I use different frameworks in Rhoar to implement the same application, which is a simple database application providing CRUD operations. So I implemented that example in Swarm, Wi-Fi Swarm. I implemented that in Spring Boot. I also implemented that in Vert.X. And in the first article you see here, I'm actually telling you how you can like incorporating dependency injection in your Vert.X application. So some will ask, oh, it's simple. I just use Spring or Spring Boot for dependency injection. But if you think about it more, you'll find that, well, Vert.X is a very small framework. If you're going to use Spring, which is a relatively large framework compared to Vert.X, so there seems to be like a huge impedance mismatch. So that's why I'm actually using Google Juice for the dependency injection. And as you know that microservices, you're free to use your own database in each microservice. So just to make it slightly different, instead of using relational databases like in my Spring Boot and Wi-Fi Swarm example, I'm going to use MongoDB. Is another good thing about it is already as an async client for me to use to deal with the database interaction. And then I'm describing how you can write JUnit tests using Vert.X. It's very different from writing JUnit tests in Spring Boot or JEE. So you find out more. And finally, I'm going to deploy it on Openshift. You'll find out how you can do that. So that is all in the first article. In the second article, I'm going to convert that application in part 1 to using like multiple verticals, and the verticals will be communicating using the event bus. So I'll come back to this later. So if you look at the event bus for Vert.X, so basically all these vertical things are, well, these are verticals. So you see that I have Java, JavaScript, Ruby, Python, Groovy, and Kosher here, right? So actually you can write verticals in different languages as long as supported by JVM. Then you can actually deploy it and they can talk to each other, and they talk to each other using a event bus. They can talk to each other. So event bus is like a JMS, but it's not JMS. It's like in memory, and when the server crashes, all the events in the event bus will disappear, right? So as you understand, whenever you're going to use JMS, there's always like overhead involved. There's some boilerplate code that is required for you to set up your vertical to either send or receive a message. So that's why in this second article that I have here, I'm actually showing you how to use code generation to generate all this boilerplate code so that you don't have to worry about it. It will create a virtual point-to-point connection like between two verticals, and they can just send message in there. In the background, obviously, is going through the event bus, right? You learn that as well, and also I'm describing how you can write JUnit tests for it as well, and finally deploying it on Openshift. And finally, there are like a couple of books that you may want to have a look. A couple of them, it may be free download as well. So have a look at these 2 books, read them. Right? So if you have more information, you need more information, you can always find more, like either from the Red Hat portal or come to my blog, here. As I said earlier, I have more articles on using different frameworks in the Rhoar runtime. Thank you very much.